This is part C. Coiling in general is a very important aspect of DNA. The ability for DNA to coil helps pack all of the DNA within the cell. If the DNA became unwound, it would not all be able to fit within the nucleus. However, replication is a process that purposefully unwinds the DNA. Replication occurs, it causes the DNA strands to separate from their hydrogen bonds, and naturally the DNA will want to recoil back in its tight structure. There is an enzyme that is specifically made to reduce the torsional strain caused when replication moves across the DNA strand. It is named gyrase, and it uses ATP to unwind the DNA as it becomes more tightly packed as replication occurs. Before replication, a normal DNA strand looks like this. If there was no topoisomerase enzyme, specifically gyrase, in replication, then it would allow the DNA strand to freely move within the cell and cause the DNA to negatively supercoil as it becomes more unwound. Another way that supercoiling comes into effect, not specifically replication. If the DNA is more unwound, there is a topoisomerase enzyme that adds supercoils to the DNA strand, and this will cause it to positively supercoil and fold back over itself. It shows how important gyrase is for replication and removing the torsional strain or helical strain that is caused by the DNA, because if gyrase was not there, the DNA would supercoil negatively and become denatured. Stay healthy. Go Pack.